So, hello student to the Foundation of Classical Electrodynamics course. So, today we have lecture 19 and we will recap the Helmholtz theorem that we discussed last day, and after that we try to do some problem. Class number 19, and we will start with making a recap of this Helmholtz theorem. So, I will just discuss about the statement. I am not going to prove the rigorous proof is there, but I am not going to prove it. But if you just understand the statement at this stage, it is fine. So, the Helmholtz theorem is saying that suppose I know the divergence of a given vector field f and curl of a given vector field f, these two are known. Now, the question is how uniquely I can predict my f. Where the divergence and curl is known. So, if I want to predict my f, so how I predict that, or what should be the form of f in terms of d and c. In order to do that, I mention that any vector field, any given vector field fr can be decomposed in two parts in general. One is the gradient of a scalar field plus the curl of a vector field v. So, this is the decomposition. I can decompose any vector field f in these two form. So, kindly note that this contain 0 curl and this component is having 0 divergence. So, I am decomposing a given vector field. I can decompose into two parts. One is having a 0 curl and another component is having 0 divergence. So, this is the way in general you can divide any given vector field. So, this is I am going to use this. Now, the Helmholtz theorem is saying that I can find my f, the scalar field which is associated with the given vector field in this form. And I can write my vector field v in this form. For any given vector field, unknown vector field whose curl and divergence is known, I can construct the F and V in this way. So, these are in general called the potential. Why it is called potential? When we do the example, then you will going to understand. So, these are potentials. So, this is a scalar kind of potential, this is a vector kind of potential, because this is a vector quantity. So, why it is called potential and what is the implication of these treatments? So, these are the overall thing. Let me repeat once again. If suppose is unknown, but I know what is the divergence and what is the curl of these f, which is unknown, but this thing is known, d and c. The thing is that would it be possible to construct f with the knowledge of d and c, and in order to do, we first divide this vector field, any vector field, into these two parts, which is the gradient of a scalar field and the curl of a vector field. So, these two combination of these two can give me f, and f should have two components, as I mentioned, one is 0 curl and another is 0 divergence. So, this is the way in general we can divide a vector field. But f and v, now these two quantity if we know, then I can predict my f, and these two quantity one can find in terms of d and c in this way. So, d c is known, so right hand side is known. So, that means I know f and v, and once we know f and v, I can find out what is my f. Now, this is in general. So, now we are going to use this for the electric field E and magnetic field B to find something. So, we will do that later also, but right now I just like to show that how for given electric field and magnetic field it works. So, for electric field E, I have two Maxwell's equation that is known. So, even though I did not cover this part, but let us consider that you know it, that divergence of E is rho by epsilon 0, where rho is a charge density, and the curl of E, that is also suppose we know, and that is 0. So, this is known. Now, it is exactly the same problem, right, that the divergence of f and curl of f is known. Here the divergence of E and curl of E is known, one is 0, mind it. So, now if I want to construct my E, because this is 0, so if I want to construct my E like the way we construct, so I should have like E is say minus of some gradient of some scalar function plus curl of some vector function, but here we can see that this quantity is 0. So, that means whatever the vector function I take here, which is depends on the value of the c, but here for electric field the c is 0. So, I should not have anything here. So, vector field vector function no longer be present in defining the electric field. So, this is 0. So, electric field simply defined in this way, and that we know, right. The electric field I can write in terms of potential, and this is exactly, if I expand if I use the Helmholtz theorem, I am going to get this one. Now, what is phi? That is rather interesting, because I know the recipe to find phi, right. So, phi, which is a function of r, according to Helmholtz theorem, it should be 1 by 4 pi and then integration divided by r minus r prime dv prime, and here we put in this region we put whatever the value I have here during the divergence, because if you know the divergence d, So, D is present here. So, according to this equation, my D is rho by epsilon, and sorry, D should not be a vector because it is a scalar quantity, and my C is simply 0. From this I can get. So, I will put this value here rho by epsilon 0, and that is basically the solution of phi. So, when you solve phi, I will get this. So, I will get 1 divided by 4 pi epsilon 0 integration rho, that should be a function of r prime, divided by at source point r minus r prime dv prime. In a similar way, for magnetic field I can extend this. For magnetic field, for magnetic field B, what we have, the two Maxwell's equation for magnetic field is, magnetic field does not have any divergence, and if I do the curl of magnetic field, it should be mu 0 j. So, this is again known. So, if this is known, then I know. So, this tells me that my D is 0 here and vector C is mu 0 j. So, I can construct my B. My B should be how much? The divergence, the gradient of any scalar field, but here the gradient portion will not be there because the divergence of B, this equation is 0. So, I will have 0 here, but the curl is very much there. So, the second part I should write, and I should write that it should be curl of some value A. Now, if I want to construct A according to the Helmholtz theorem, A, it should be 1 by 4 pi, then integral divided by r minus r prime dv prime, and here I should put, in this region I should put whatever the curl value that is given. The curl of B is mu 0 j, which is C here. I need to put C here, C is mu 0 j. So, I should put mu 0 j here. So, eventually my A becomes mu 0 divided by 4 pi integration of j function of r prime and then r minus r prime dv prime. So, here this scalar quantity phi is called the scalar potential. This is also a potential. So, it is called the scalar potential, and this quantity A is called the vector potential. So, that we will discuss in the later class. Obviously, we are going to discuss in detail, but in the context of Helmholtz theorem, which is a generalized theorem, you can see that for electric and magnetic field how one can apply that, and after the application you can find out the scalar potential and vector potential just by using the recipe of this Helmholtz theorem. So, you should remember that, because in the later part we will discuss again in more rigorous way. So, now after that I am planning to have some tutorial today. So, few problems I like to solve. So, let us do that. So, it is say tutorial 1. So, problem 1. So, the problem 1 is this. So, show that A cross B dot A cross B is equal to A square B square minus A dot B square. A vector identity you need to prove by using the Levi-Civita symbol that we learned in earlier classes. So, let us do that. How to do it? So, this quantity, if I write the ith component, so the ith component will be epsilon I j k, then it should be A j B k, and then it should be multiplied by the ith component of the next term, which is epsilon I L m. I am not going to use j k anymore, L m, then A L B m. Then I have epsilon I j k, epsilon I L m, and then I have A j B k, A L B m. Okay. So, now this we know that when we have epsilon I j k and epsilon I L m, then it is associated with a delta function, and this delta function is this delta I. If it is I, then it should be delta j L delta k m minus delta j m delta k L multiplied by the rest term, which is A j B k, and then A L B m. Okay. So, if I execute this, what I get? So, j is there, L. So, so the first term is A j B k. So, j and L are here. So, okay, let me write it here. So, A j I write, and then L has to be, this L has to be j. So, I can write A j square here. If I write B k, fine, but this m has to be k. So, I can, the first term will be simply A j square B k square. What about the next term? Minus. So, A j is there, I can put A j. So, then m should be j. Okay. So, okay, B k is also there, so I put B k. So, A L should be A k, and B m here should be B j. So, this quantity is simply a j square b k square, but this one if I write properly, it is okay. Here I am making mistake. So, j m should be, so here it is I am having m. So, this m should be j here, then delta function is 1. So, m should be j here. So, I have a j b j and then I have a k b k. Okay. So, this quantity is simply a square b square without any doubt. But this quantity is a dot b and then again another a dot b, because a dot b is written as a k b k or a j b j. So, that is the thing we wanted to prove, because this is the thing we wanted to prove and we prove it. This is one kind of problem. Okay, let us go to the next problem. The next problem is problem 2. So, problem 2 is saying that if I have curl cross lambda is a constant and g, so that this quantity is equivalent to lambda cross g minus g cross lambda. Okay. So, we need to show this identity. So, again let us start with the left hand side, whatever we have. So, we have a curl here. So, we know how to represent curl. So, curl is epsilon I j k and then del j and then lambda g vector kth component, okay, that we have. So, this if I elaborate, because this is a derivative. So, this if I elaborate, we have I j k, then this portion I am now writing. So, lambda then del j g k plus g k del j lambda. Okay. So, lambda is a scalar. Okay. So, from here I can write lambda this from this, then epsilon I j k del j g k. So, this is forming something and plus other term epsilon I j k, then we have g k del j lambda. So, this you can see quickly that this is nothing but lambda and then curl cross g, right, lambda curl cross g. What about the next term? Because here we have j and k, here we have k and j. So, if I now change it with a by putting a negative sign, then it should be epsilon I and then k j and then g k del j lambda. If I do, then I can have a orientation here, and this orientation is curl of g, sorry, not curl, because here, so we have a orientation like G cross this quantity. This is the divergence, the gradient of lambda. So, overall what we find? So, overall we find that my final result is lambda curl of G minus G cross divergence of lambda. This is precisely we need to prove. So, this is the thing we need to prove, and we prove it here. Okay. So, this is a second kind of problem. Now, let us go to another problem. The problem 3 suggests that suppose H is x y square I plus x square y j, right. This is a vector field. So, the question is find out the line integral along the parabola x equal to y square, joining the point P, one point is P, which is 1 1 0, to Q, another point which is 16 and then 4 and then 0. Okay. So, it is in 2 dimensions because z axis, z point is 0. So, how the path will look like? Let us first determine the path and then we will execute this line integral for a given vector field. So, this is my y axis and this is my x axis, x y, and if I plot it, it is a parabola. So, it will be something like this, okay, something like this. So, 2 points are mentioned, one is here, say this point is Q and another is here, this point is say P. The coordinate of this point is 16 4 and coordinate is 1 1. My drawing is not in the scale, but you can understand that. Okay. So, I need to integrate it over this point P to Q. So, this is my line element, from P to Q, and I need to integrate the given function, this one, this is the given function, given vector field. So, okay. So, I know how to integrate this. So, the line integral, if I calculate, it is h dot dl, okay, which is, so what is dl? This is a Cartesian coordinate system, so easy. So, we have dxi plus dyj. So, I can put the value of h here, which is x y square integral L x y square I plus x square y j dot dx I plus dy j. Okay. So, this quantity if I now find, it should be x y square dx integration, one integration, and another integration will be from p to q. This is also from p to q. Another integration is saying this is x square y dy. Okay. Now, please note that over this line we have a relation, and this relation is this. This relationship is already given. So, this is having a relationship, and that is y equal x equal to y square. So, this is the way x and y is related over this line. So, we will going to use that. So, I have say x equal to y square, and then dx is equal to 2 of y dy. Okay. Then I am going to use this here in this expression. So, I need to find out integration p to q, the line integration d dot dl, and here if I convert everything in terms of x, then my limit should be simply 1 to 4. So, 1 to 4. No, if I convert everything, so because x is 16, so y is 4. So, my limit is 1 to 4 if I convert everything in terms of y. You can do that everything by converting x, it is up to you. So, the first is x, I just write y square, and y square is already there, so another y square, dx is 2 y dy, that is the first integral, everything in terms of x. What about the second one? 1 to 4, and x square I simply write y to the power 4, and y I should write y, and dy is already there. So, I have here this quantity 2 integration of y to the power of 5 dy plus integration of 1 to 4 plus integration of 1 to 4 y to the power of 5 dy. So, this is simply 3 integration of y to the power of 5 dy 1 to 4. So, we have 3 multiplied by y to the power 6 divided by 6 with the limit say 1 to 4. So, this is half, and then I have 4 to the power 6 minus 1. So, this is the value of the integration one can have. Okay, so, I do not have much time today to do the other problems. So, let us meet in the next class and discuss more about the problem. So, the next class tutorial will be continued, and we will going to solve few problems there. With that note, I would like to conclude here. Thank you very much for your attention, and see you in the next class.